Hi, my name is Jain from Vidyanan Online, and if you're new to this channel, then let me tell you that we at Vidyanan provides education resources to the students of class 9 and 10th. Now in this session, today we are going to study about indicators. So far we have studied about what are acids, what are bases, what are the properties of acids, what are the properties of bases, and what is pH and its application. So, there are 118 elements known at present, and these elements combine in order to form compounds. Now, we need to know whether these compounds are acidic, basic or neutral. For this, you can say, we can actually taste them and say if it's sour, then it's acid, and if it's bitter, then it is a base. But is it possible that you can taste every compound? Because not every compound is suitable for us to eat. So now comes the role of indicators. So indicators actually helps us to tell whether the given compound is an acid, base or a neutral compound. Now I have categorized these indicators as natural indicators, synthetic indicators and olfactory indicators, and we have also studied about universal indicator. So universal indicator will tell you the strength of acid and bases. After that, we have summarized the whole session so that in a go you can understand the whole session. It is going to be a wonderful session. So let's start with that.
Now the first question which arises is, what is indicator? Right? So indicator is just like a dye. The way we use dye in order to color our clothes, in order to color our hair, and also in order to provide colors to our food. In the same way, this time we are going to use the indicator in order to check whether the solution is acidic or basic. Okay, so we can say indicator is a dye that changes its color when put into an acidic or basic medium. Next, it tells whether the substance is acidic or basic by changing its color. So whenever you put an indicator in acidic or basic medium, it would change its colors in order to tell you whether the medium is acidic or basic. I'll show you how. So all the acid and base indicators which we are going to study now will be weak acids or weak bases. Let us categorize them. So first we have natural indicators. So what are natural indicators? These are the indicators which are found naturally and they change their color in acidic or basic media. Okay, so examples include litmus solution or a litmus paper, turmeric, red cabbage extract, petals of some flowers like hydrangea. Next we are going to talk about synthetic indicators. So what are synthetic indicators? These are the indicators which are man-made. Okay, they are not obtained naturally from a nature. They are man-made. Examples include methyl orange, which is very important, and phenolphthalein. Last is olfactory indicators. So what is olfactory? It is actually related to the odor. So indicators which change their smell in acidic or basic medium are olfactory indicators. That is, their smell will vary. Example include onion, clove oil and vanilla extract. Now let us study them one by one. So first we are going to study about litmus. So litmus is the most common indicator that is used for testing acids and bases in laboratory. The litmus is basically purple in color. So the neutral color of litmus is purple, or the natural color of litmus is purple. Now litmus is basically a dye which is obtained from lichens. So what are lichens? Lichens are basically combination of algae and fungus. So lichens are the organisms from which we obtain litmus. Now the litmus is available as litmus solution as well as litmus paper. Now this purple color solution of litmus is made into blue litmus solution and red litmus solution, which I have mentioned here, blue litmus solution and red litmus solution, for the sake of convenience. Also, whenever you will dip this solution into paper, you will get litmus paper. So if you will dip the red litmus solution into a paper, you will get a red litmus paper, whereas if you will dip the blue litmus solution in a paper, you will get the blue litmus paper. Also, the litmus is a weak acid. Now let us explain that how litmus changes its color when it comes in contact with an acid or a base. Now we have a beaker here, and this beaker consists of some solution. Now we need to check whether the solution is acidic or basic. Okay, for this, first of all, we'll dip a blue colored solution to it. Okay, and if the color will change from blue to red, it means that the solution is acidic. Okay, so here if you see, after adding the blue color litmus solution to this beaker, the color of the litmus solution changes to red, right? So this means that the solution was acidic. So now this can be very confusing. Acid, base, red, blue. So what can we do is, we can understand this mnemonic, and which is A, B, R. So we all know after A it comes B, okay, and then you have to write R. So ABR. So acids turn blue litmus solution to red. In that way you will be able to conveniently learn this term and you won't get confused. Okay, now let us see what will happen if we add red color litmus solution in the basic solution. So you have a beaker here which consists of a basic solution. So here is the basic solution in this beaker. Now in order to test whether this is confirmed a basic solution, what we are going to do is, we are going to add a red color litmus solution. So after adding this red color litmus solution in the beaker, this solution will react with the basic solution and the color of red color litmus solution will change from red to blue. And if the color of the red color litmus solution changes from red to blue, then it is confirmed that it is a basic solution. So here if you see, the red color litmus solution is changed to blue color, which confirmed that the given solution was a basic solution. So for basic solution we have the mnemonic device BRB. And what does that mean? It means that basic turns red litmus to blue, or you can also say B to B, which says that basic turns the litmus into blue. So whenever you add a red litmus solution to a basic solution, then the color of the litmus solution will change from red to blue. Now let us see this example. So as of now we have studied that acids turn blue litmus to red and bases turn red litmus to blue. Now what we are going to do is, we are going to check what will happen if for acid we make use of red litmus and for base we make use of blue litmus. So here you have a beaker in which you have an acid. Now to this acid we are adding the red litmus solution. So once you add the red litmus solution to this, the red litmus solution will get in contact with the acid and it won't change the color. The red litmus will be red litmus only, and that is why you will not be able to see the change in color. Similarly, if in the beaker you have a base and now you are using the blue litmus solution for it. So when this blue color litmus solution will come in contact with the base, the change of color is not observed. That is, the blue color remains the same. Okay. Now let us understand this question. So you have 3 beakers out here and you have one red litmus paper here. Now you need to test in which beaker you have acid, distilled water and base. Now for acid we know acid turns blue litmus to red, whereas the base turns red litmus to blue. And for distilled water, which is neutral, there will be no change in color. The red color litmus paper will remain the red. Now first of all we are going to dip this red color litmus paper in this first beaker A. Okay. Now after dipping this red color litmus paper, we find that there is no change in color. So then what can you say about A? Then A can be a neutral solution because there is no change in color, or it could be an acidic solution. Why? Because acidic solution only turns blue litmus to red. And if you are adding the red litmus, the color will not change. It will be red only. Okay. Now let us try the strip on the beaker B. Now for beaker B, when you add the red litmus paper to it, the color is changed from red to blue. So then what can we say about B? We can say that the beaker B consists of a basic solution. Why? Because only basic solution changes the red litmus to blue. So this is for sure that B consists of basic solution. Now after dipping this red color litmus paper into the beaker B, now you are having the blue color litmus, right? And now if you are dipping it in the beaker number C, so if the color is not changed, it means that C is a distilled water, right? Because distilled water is a neutral one, it won't change the color. Whereas if you dip this blue color litmus paper into this A bottle, the color will change from blue to red. So this is how you are going to solve this. So as I told you before, you can use litmus in two ways, as litmus solution and as litmus paper. Now many a time it is very convenient to use litmus paper because it is very handy. So how can we prepare the litmus paper? So whenever you will dip the paper into red litmus solution, then you will get the red litmus paper. Whereas when you will have the paper dipped in blue litmus solution, then it will give you the blue litmus paper, the way it is shown here. So this is red litmus paper which is showing the change in color after dipping in the solution, whereas this is blue litmus paper which is showing the change in color after dipping in the solution. So this is acidic solution because it is changing the color from blue to red, whereas this is basic solution because it is changing the color from red to blue. Let us see the second indicator, which is turmeric. Okay, so the most common household spice is turmeric, which comes in yellow color. So the neutral color of turmeric is yellow color. Now it doesn't change any color in acidic medium. So if you put the turmeric in any of the acidic solution, the color of turmeric will not change. However, if you put the turmeric into basic medium, say suppose in soapy solution or into detergent, then the color will change from yellow to reddish brown. So turmeric changes the color in basic medium. Now it is a weak base and that is why it is bitter in taste. Now let me explain you this turmeric test with an example. Okay, so by mistake a yellow colored curry had fallen on your white shirt, that gives yellow stain to it. Now why the stain is yellow? It is all because of the presence of turmeric in the curry. Now the next step you are going to do is, you are going to scrub this yellow stain with the help of soapy solution. Now as soon as you did this, the yellow stain is converted from yellow to reddish brown, and now you are wondering what is this? The color is changed to much brighter color. So this is because the turmeric is actually the indicator which on reacting with the basic solution has changed its color from yellow to reddish brown. Now as soon as you rinse this cloth with lot amount of water, then the soapy solution gets removed from the white cloth and the yellow color is shown again. So what can we say about turmeric? We can say that turmeric doesn't change color in acidic medium, okay, whereas for a basic medium it changes the color from yellow to red or reddish brown. Now let us see the next natural indicator, which is red cabbage extract. So red cabbage extract is basically obtained from red cabbage leaf, which is actually shown here in this picture also. Now it is neutral color is red. So it remains red in acidic medium, that is it doesn't show any change in color in acidic medium. However, the change in color is shown in the basic medium. So it changes from red to green in basic medium. Next is how the flowers can actually act as acid-base indicators. So basically colored petals of some flowers changes color in the presence of acid and base. For example, you have flower like Hydrangea, Petunia and Geranium. Now these are their pictures. So Hydrangea is basically blue in color, then you have Petunia and you have Geranium. Now if we talk about Hydrangea plant, So it is basically blue in color. Now what happens is, if you put this blue colored petal into this basic solution, then the color changes from blue to pink, which indicates that the solution was a basic solution. So till now we have studied about the natural indicators. Now we are going to study about synthetic indicators. So what are synthetic indicators? These are the indicators which are man-made. Okay, now in synthetic indicators we have methyl orange, which is very famous, very common. So what is methyl orange? It is actually a synthetic indicator having deep orange color. So its neutral color is deep orange. Now its color changes in both acidic as well as basic medium. Also it is a weak acid. So let us see what happens when you have methyl orange in acidic and basic medium. So methyl orange indicators give yellow color in basic medium and it gives red color in acidic medium. So here if you see this is methyl orange, which is deep orange in color, and in acidic medium the color is changed to bright red, whereas in basic medium the color is changed to yellow. Okay, so this happens with methyl orange, it changes its color in both the mediums. Now let us talk about phenolphthalein. Phenolphthalein is yet another synthetic indicator which is most commonly used. It is a colorless solution which changes its color only in basic medium. So it doesn't change its color in acidic medium. The only change in color is obtained in basic medium. Again, it is a weak acid. So here if you see, you have phenolphthalein here, and for a pH is equal to 7, the phenolphthalein is colorless, whereas for pH is equal to 10, it means a basic solution. The color is changed from colorless to pink color. So here if you see, phenolphthalein indicator is colorless in acidic medium, that is, it doesn't change its color in acidic medium. Whereas if we talk about the basic solution, so it changes its color from colorless to pink. So here if you see, this is the basic solution and this is phenolphthalein which is added to this basic solution. Now as soon as the phenolphthalein is added to this basic solution, the color of phenolphthalein is changed from colorless to pink. Let us talk about olfactory indicators now. Now this is another kind of indicators in which the characteristic smell of the indicator changes. So we know that onion has a pungent smell, whereas the vanilla has a sweet smell. Now let us see what will happen when they are added in acidic or a basic medium. So first of all, let us talk about the principle of olfactory indicator. So olfactory indicators works on the principle that when an acid or a base is added to it, its characteristic smell cannot be detected. So talking about onion, so its pungent smell is not at all altered in acidic medium. So if you put the onion into an acidic medium, its smell will remain the same, it won't disappear. But talking about the basic medium, suppose you have put it into sodium hydroxide solution, which is a basic solution, then its pungent smell will disappear. Same goes for vanilla also. So vanilla sweet smell is not altered in acidic medium. However, if you put this vanilla essence into a basic medium, then its sweet smell disappears, confirming that the medium was a basic medium. Now let us talk about one of the most important indicator, which is the universal indicator. Now question arises that we have so many indicators studied. We have studied about natural indicators, synthetic indicators and olfactory indicators. So why do we need to have universal indicator? So the answer is, all those indicators like methyl orange, litmus, phenolphthalein, turmeric, they were able to tell whether the given substance was acidic or basic, but they cannot tell whether they are weak acid, strong acid, weak base or a strong base. So they cannot tell the strength of the acidic or a basic medium. Okay, now let us talk about the definition of it. So universal indicator is a mixture of different dyes. It is a mixture of different indicators that produces different colors at different concentration of hydrogen ions. Okay, so if the hydrogen ion is high, the universal indicator will show different color. If the concentration of hydrogen ion is low, it will show different color. Okay, let us see how. So, universal indicators tells us the strength of the acidic as well as basic solution. I told you this before. So, this is the picture of universal indicator which on dipping in different medium changes its color. Also, they can be used both as solution, which is available here, which is mentioned here, and also as indicator paper, which is mentioned here. Okay. Now what happens is universal indicator undergoes a change in color when the solution of the substance to be tested is dropped on it. Okay, so what does that mean? It means that if you put the universal indicator solution to any of the substance which needs to be tested, then the color will change. And now what you are going to do is you will match that changed color with the standard pH chart, and you will test whether the substance was a neutral one or weak acid, strong acid, or weak base or a strong base. Now let us summarize this session. So let us first talk about litmus. So litmus, in acidic medium we have the mnemonic ABR. So acidic medium changes the blue litmus color to red litmus, whereas in basic medium the red litmus solution is changed to blue. Now talking about turmeric, so turmeric is yellow in color. So in acidic medium there is no change. In fact, let me tell you that for most of the indicators there will be no change in acidic medium. Okay. And talking about in basic medium, so the color becomes bright, it becomes reddish brown. Okay. Red cabbage extract, its neutral color is red and it remains red in acidic medium, but for basic medium it changes from red to green. Now talking about the petals of hydrangea flower, so hydrangea flower is basically blue in color. In acidic medium its color is not changed, whereas in basic medium the color is changed from blue to pink. Talking about methyl orange, it is a synthetic indicator which is deep orange in color. Okay, so in acidic medium the color becomes more brighter and is changed from orange to red, whereas in basic medium the color fades and thus there is change from orange to yellow. Talking about phenolphthalein, it is a colorless indicator which doesn't show any change in acidic medium, whereas in basic medium the color is changed from colorless to pink. Talking about onion extract, it is an olfactory indicator which shows no change in the smell in the acidic medium, whereas its pungent smell disappears in basic medium. Same as with vanilla essence, no change in the acidic medium, whereas smell disappears in basic medium. So if you can see here, for maximum we have no change in acidic medium. Only for litmus and for methyl orange there is change in acidic medium.
I hope you must have enjoyed this session. In the next session, we are going to study about salts and its properties. For this, you need to subscribe our channel and click on the bell icon. Till then, bye-bye and take care of yourself.